Welcome back to Boson Buzz. I'm Monty Molecule. Look at this little ring. For thousands of years, we've treasured gold. We've fought wars over it, built economies on it, and given it as a promise of love. But here's a question that stumped every ancient civilization. Where does it actually come from? It doesn't grow in the ground like a potato. The answer, it turns out, isn't found in a mine on Earth. It's written in the sky, in the violent, spectacular death dance of the universe's most extreme objects. This is the story of the cosmic factory that forges the heaviest elements in creation, and how we learned to read its fiery signature from 100 million light-years away. To understand the cosmic forge, we need to start with a cosmic kitchen. Imagine the universe as a giant kitchen, and stars are the chefs. For most of cosmic history, there was only one recipe: nuclear fusion. Inside the immense pressure cooker of a star's core, simple elements like hydrogen are fused together to make heavier ones: helium, carbon, oxygen, all the way up to iron. This stellar cooking provides the ingredients for planets and life itself. But there's a limit. Fusing atoms into anything heavier than iron doesn't release energy. It consumes energy. A star can't make gold or platinum in its core. It would be like trying to start a fire by throwing water on it. So, for a long time, the origin of these heavy, precious elements was one of astronomy's great mysteries. The first clue was the supernova, the spectacular explosion of a massive star. In its final, catastrophic death throes, a supernova unleashes such unbelievable energy that it can briefly force atoms together into heavier elements. For decades, we thought supernovae were the universe's primary goldsmiths. But the numbers never quite added up. There didn't seem to be enough supernovae making the right kinds of elements in the right amounts. There had to be another, even more powerful kitchen. The suspects were exotic, almost fictional objects: neutron stars. Imagine taking a star more massive than our sun and crushing it down into a ball the size of a city. A single sugar cube of this material would weigh as much as a mountain. It is matter pushed to its absolute breaking point, where atoms cease to exist and everything is just a dense soup of neutrons. These stellar corpses often come in pairs, orbiting each other in a silent, deadly waltz. And as they orbit, they lose energy, emitting ripples in the fabric of space itself, gravitational waves. Over hundreds of millions of years, their dance decays. They spiral closer and closer until finally, they collide. The collision of two neutron stars is the most violent event in the universe since the Big Bang. Imagine two city-sized spheres, each containing more mass than our sun, spinning around each other hundreds of times per second before smashing together. The forces involved are beyond human comprehension. For a brief moment, the collision outshines every star in its galaxy. But the real magic isn't in the blinding flash of light, it's in the incredible fallout. The impact is so titanic that it shreds the very fabric of the neutron stars, blasting a jet of their innermost material into the surrounding space at nearly the speed of light. This ejected material isn't normal matter. It's a superheated, expanding cloud of neutrons so unimaginably dense, it's like a neutron soup, a cosmic broth where the normal rules of atomic stability are turned upside down. This cloud is the universe's ultimate forge. Inside it, conditions are more extreme than in the core of any supernova. Atomic nuclei, like those of iron, are caught in this storm. They are bombarded by a blizzard of free neutrons, particles that normally reside safely inside atomic cores. Here, they are loose and abundant. This frantic bombardment happens at a rate so fast it's called rapid neutron capture, or the R process. Think of it like a small, sticky snowball rolling down a hill during the fiercest blizzard you can imagine. Instead of gently picking up a few snowflakes, it is pelted from all sides by millions of them all at once, growing to an enormous size in mere seconds. In the same way, an iron nucleus doesn't have time to adjust or decay radioactively as it normally would. It greedily captures dozens, even hundreds of neutrons in a chaotic, frantic rush, transforming in the blink of an eye into a heavy, unstable nucleus of elements like gold, platinum, or uranium. In that single, spectacular cataclysm, more gold is created than humanity has mined in all of history. The forge has fired just once, and its precious, heavy products are sprayed like cosmic confetti across interstellar space. For a long time, this was just a beautiful theory, proving it meant catching one of these incredibly rare events in the act. The breakthrough came on August 17, 2017. Gravitational wave observatories on Earth felt a distinctive chirp in spacetime, the signature of two neutron stars merging. For the first time, we had an invitation to the collision. Astronomers around the world swiveled every telescope they had towards that patch of sky. What they saw was not a supernova's brilliant flash, but something new, a kilonova. A new point of light appeared in a distant galaxy, glowing not white, but a profound red gold. This was the radioactive glow of the freshly forged heavy elements decaying. The light was the literal glitter of gold and platinum cooling in the vacuum of space. The theory was spectacularly confirmed. We had witnessed the forge at work. But scientists needed more than just a pretty light. They needed a fingerprint. Light can be split into a spectrum, a barcode of colors specific to each element. As the kilonova faded, they analyzed its spectrum, and there, in the data, were the unmistakable barcodes of tellurium, strontium, and finally, the subtle but definitive signature of atomic gold being created in real time, over 100 million years ago. The evidence was now irrefutable. The gold in your jewelry, the platinum in a catalytic converter, the uranium in some power plants. They are all the ash from a stellar collision that happened before dinosaurs walked the Earth. We are literally wearing stardust from a cosmic crime scene. This discovery rewrote the periodic table's origin story. Neutron star mergers are now considered the universe's primary source of the heaviest elements. These rare, catastrophic events are the ultimate recyclers, taking the burnt-out cores of dead stars and transforming them into the seeds of new planets and, ultimately, life. Every heavy atom in your body is a survivor of this incredible violence. The implications stretch even further. The leftover core of the merger likely collapsed into a black hole, but for a fleeting instant, it may have been the most massive neutron star ever, a laboratory for states of matter so extreme they can't be recreated on Earth. By studying the light and gravitational waves from these events, we are probing the fundamental laws of physics under conditions of unimaginable density. So, the next time you see something made of gold, remember its incredible journey. Forged in a cataclysm of colliding stars scattered across the galaxy, incorporated into a cloud that formed our solar system, buried in the Earth's crust, mined and shaped by human hands. It connects the most violent events in the cosmos to the most intimate moments of human culture. It is a permanent reminder that we are not just in the universe. The universe is in us. From a silent dance of dead stars to the glitter in a ring. That's the epic story written into every atom of gold. It teaches us that the universe isn't just a void. It's a dynamic, creative, and sometimes violently beautiful place where even destruction leads to new creation. We are the beneficiaries of that ancient stellar alchemy. If you find it awe-inspiring that your personal story is woven from threads of cosmic history, please help Boson Buzz keep exploring. Give this video a like and subscribe to follow the trail of discovery. Until next time, have a safe and curious week.